Welcome to a short video presentation about a product which is new, innovative and unique from SKF Maintenance Products.
It's the SKF Electrical Discharge Detector pen.
Electrical Discharge Detector pen. So what exactly is it detecting?
Well, in electrical motors, for many years, we faced some kind of phenomenon called electrical erosion. It's been known for years and years. But especially since the mid-90s, with the introduction of frequency drive, variable frequency drives, with what they call a PWM concept or typology. It's pulse width modulated drives. They have some components like fast switching transistors, IGBTs. They are brilliant electronics or power electronics that really cut the cost on electricity. So we have a really gain in energy by using drives. But the drawback of that is that the bearings started to suffer from an old disease that was back to the scene again, electrical erosion.
So do all electrical motors powered by a VFD, a variable frequency drive, suffer from the problems of electrical discharge?
That's the thing. Potentially all of them can suffer from it, but they don't all do that, depending on some parameters, settings, installations, and so on. And we're going to talk about that a bit later.
Okay. Is there any other way you can detect electrical discharge in a bearing at the moment?
Unfortunately, not much. You can really see that the bearing is suffering from electrical erosion once you dismount it and inspect it. So basically it's too late.
It's too
so
late.
Broken
okay.
bearings, like fluted.
Yeah. And could you use maybe vibration analysis to see if there's electrical discharge effects in the bearing?
Sure you can, but again it's like quite an advanced stage of the damages that have occurred. So it's again too late. Once you have vibrations, you know that you will have to replace the bearing fairly soon.
Okay, so this new product here should be able to detect the phenomena in an early stage.
Exactly. What we want to do is really an early diagnosis of electrical erosion taking place in an electrical motor.
So it's a proper predictive maintenance tool.
Absolutely. We want to focus on the predictive checking or actions in order to really do some proper preventive maintenance. We want to really plan the next maintenance on the motor to take actions. If we can't take actions on short term.
So you mentioned electrical discharge in the bearing, but what exactly does the electrical discharge do to the bearing itself?
Well, first of all, let me tell you a bit about why we have electricity going through the bearings. So to make it simple, with the introduction of variable frequency drives, some kind of parasite currents have been created in any electrical motor driven by a drive. And those currents, they want to find a way out of the motor, and they usually go to the shortest or the path with the least resistance, and they usually go through the bearings. And by going through the bearings, they really have to cross over the grease film from the rolling elements to the raceways, or to the raceways to the rolling elements. And that has created a lot of damages.
So how do these electrical discharge currents cause the damage?
Well, it's like having a spark or an arcing inside the bearings, you know, thunderstorms, the lightnings. So on a small scale, that's what happens. And every time you have some spark, locally, if you look with a microscope, you would see the metal melting and resulting in a damage on the surface of the rolling elements or the raceways of the bearing. When it comes to thousands microcraters, we talk about microcratering, and this is really damaging the surface of the rolling elements or the raceways.
So that can't be good for the bearing?
Oh no, absolutely not. That's the early beginning of even more damage to the bearings.
So you say it's microcratering, but can I see anything with the naked eye?
When we go to the stage after microcratering, we have fluting or fluted bearings, and then it's very obvious for naked eyes. It's like having grooves all over the bearings or the rolling elements. And also on the lubricant part, you can see that the grease can easily be burnt, so it's totally blackened.
Yeah, I can see here the burnt grease obviously doesn't provide a good lubrication film, so the bearing will fail quite rapidly.
Oh yeah, electrical erosion will reduce dramatically the service life of the bearing.
Yeah, you said electrical discharge like a spark in the bearing. I guess it's a bit like a cigarette lighter.
Yeah, exactly. If you have an electronic lighter,
I happen to have one here.
I know you do.
Yeah.
Basically, the origin of the spark is electrical. And that's exactly the kind of electrical discharge that happens or that takes place in a bearing. And we can detect this kind of phenomenon exactly.
So you can detect it now with this
Oh
instrument
yeah,
here?
absolutely. We
Okay.
can do a demonstration.
Then show me.
So first of all, we have to switch it on, obviously.
Right, here comes a segment check to start with.
Yes.
Make sure it's working. Yeah.
Absolutely. And then you have 0 displayed because we are not detecting actually. To start detecting, we have to press once more short press on the top button.
And now it's in detecting mode. So I've got a cigarette lighter here. So I'll just try.
Of course. Every time you create a spark, that's what we detect, because of the electrical discharge created by the lighter.
I can see there's another button here. What does that do?
It's a time selection, time-based selection. We've chosen to go for like 3 different time possibilities: 10 seconds, 30 seconds, or indefinite time, just like we did with the lighter. Basically, when the electrical discharge detector pen is on, we can go from indefinite by default, or 10 seconds, 30 seconds, or back to indefinite again.
So I can see that's useful if you're measuring similar machines and under similar running conditions and you want to compare them. It'd be better to choose a time base, for example 10 seconds or 30 seconds.
Absolutely. When you have a full population or a big park of motors in the same, doing the same thing, like the same applications, then you can easily check them all within like 10 seconds each motor. And if there is a black sheep in the group, you can really identify it better than the others.
Well, I've got a better idea how it works now. I've got a motor with a variable frequency drive. You're going to show me how it works?
Perfect, yeah. Let's go.
So I noticed when we were using the ED pen, close to the electric motor, there were some numbers on the screen. What does that tell us?
It tells us 2 things. First of all, because we had numbers and not only 0, it means that we have detected electrical discharge. So it means that potentially this motor is suffering from electrical erosion. Second is that those numbers kept on increasing. So basically, these numbers show us that we have a perpetual occurrence of electrical discharge in the motor. This number that we had on the screen was exactly the number of electrical discharges we were counting. If you have, for example, an oscilloscope plugged onto the shaft and the housing of the motor, we could potentially measure those peaks or monitor those peaks.
So we're doing the same as an oscilloscope, but remotely?
Exactly, exactly. Oscilloscopes are another method for detecting electrical discharges, but as you notice, in this kind of environment, it's not easy to bring an oscilloscope. You need a special probe on the shaft, and you need knowledge on electrical motor currents to do this monitoring.
Yeah. So, okay, we went and had a look at an electric motor. So that's the sort of thing a maintenance technician could do. Who else would use such an instrument?
Oh, a lot of people. I would think of rewinders, like electrical motor rebuilders. They would use this kind of device to really do a quick diagnosis and doing a normal maintenance routine. For instance, it's not unusual to do vibration analysis once in a while. So why don't you take the ED pen and do also analysis once in a while on those motors and see the variation of the numbers with time?
But that seems a good idea because you can do it very, very quickly.
Absolutely.
Yeah. Another thing I noticed, you were quite precise in where you were holding the ED pen. near the motor. Does it matter the distance you have the head pen from the motor?
Yes, yes. The closer you are to the bearings in the motor, drive-in or non-drive-in, the better you can detect the phenomenon. And of course, if you do some monitoring on that same motor several times, always try to be at the same position and have the motor running in the same conditions.
Oh, so it's similar as you would use for, let's say, vibration analysis with COMO or with a thermometer?
Yes.
You always measure at the same point?
Exactly, the same operation conditions all the time to compare apples with apples.
So if I keep having bearings suffering from electrical erosion, what solutions can we offer?
Oh, there are plenty of solutions. On the short term, you can decide to have a better grounding of the motor, or like shaft grounding, better earth connection to the housing. And of course, you can plan your next maintenance step with replacing some bearings with insulated bearings or intercoats, or hybrid bearings, or also called ceramic bearings. And these are the only solutions today that are really efficient in preventing from electrical erosion.
So that's good, so you can detect the phenomenon and also have a solution as well.
Yes.
Another one small question, what other features does the EdPen have?
Oh, we went for simple features that makes life easier. If you work in a dark area, we have a small backlit screen, so that's the second button as well. And in order not to waste the batteries, there is an auto-off function on it.
So this instrument is truly unique. It can detect electrical discharges in bearings remotely, and it's the only instrument that's available at the moment worldwide that does this.
Yes.
Yeah? And it's available globally from SKF. You can get more information from your local distributor or look online at www.mapro.skf.com.